Hi guys, so we're going to be going over station D of the kinematics lab. So for this station, we're going over angular kinematics. So when we're talking about angular kinematics, we know that torque is implied. So torque is a rotational force, and the equation for that is force times R. So R equals perpendicular distance from the line of action. So for example, we're going to be looking at this door from the top view down. This is the axis of rotation. This is the total length of the door, which is 4 feet. Our force would be applying upwards, while our perpendicular line of distance, or perpendicular distance from the line of action, is this direction. All right, so let's go over the examples. So example 1, we have a force of 20 newtons and a distance of 4 feet. Then we'll input those numbers inside the equation. 20 newtons times 4 feet equals 80 newtons per feet. Now for example 2, we have 40 newtons and 2 feet. Input the numbers. Torque equals 80 newtons per feet. So we see here that although they have different numbers, they end up having the same amount of torque. So how this is explained is if I apply 20 newtons right here over the distance of 4 feet, I will have a total torque of 80. However, if I apply my force in the middle at 2 feet, I will have to apply double the force of newtons to have the same amount of torque. So that would be 40 newtons. All right, so now let's go over angular distance. So angular distance, we know that 1 revolution equals 360 degrees. For example, let's say we go 2 rotations clockwise, meaning this is a vector quantity because it has direction. Then, therefore, you go 2 circles clockwise, then we would know that the direction is negative. Same thing with counterclockwise, it'll be a positive rotation. Okay. Angular displacement. So let's say we go a total of 1 full circle, or a half rotation. We'll do a half rotation first. Come over here. We have a total displacement of 0.5, so half. However, if we do a full rotation, all the way back to the starting position, then we have an angular displacement of 0, since we ended up in the same position.